Hello there. We're going to do another finite difference table, this time doing one where the formula is not a polynomial. So, first fill out the entries in here. When n is 0, 5 times 3 to the 0th, that's just 5 times 1, so that's going to be 5. And this is exponential growth. We're tripling each time, so that's going to be 15, 45, 135. This one's a little bit bigger, 270 plus 135, 405, and then 4 times 3 is 1215. Then we'll look at the finite differences. So when I subtract these, I'm going up by 10, I'm going up by 30, going up by 90, I'm going up by, what is this one, 270, and then 810. So actually, we can see a bit of a pattern here where it really looks like I'm doing 10 times 3 to whatever power that I'm on. That looks like it's going to be the finite differences. So for example, if I'm here on the third stage and I want to get to the fourth, I'm going to be adding 10 times 3 to the third, which is 10 times 27, or 270, to get up to the next one. Okay, so we're going to want to prove this rule again. For the n plus 1, remember that's the next one, then we minus the previous. 135 minus the 45 gets us that we're going up by 90. For that, I'm going to stick in n plus 1 everywhere that I see it in this equation here. And then I'm just going to subtract the original one. This one, I'm not actually going to worry about putting it all in brackets this time, because there's not all that much there to begin with. If I had multiple terms, I'd probably put it in brackets. So I just get that. Okay. Now what do these have in common? Well, they both have 5s in them, so I can factor out a 5. Alright, so now I got just the inside part, 3n plus 1 times 3 to the n, and this can actually be, I can factor out a 3 to the n. Now, if you're not comfortable with this, let me just slow it down a little bit. So 3 to the n plus 1, that's the same as 3 times 3 to the n, and now both of these have 3 to the n in them, so I'll factor that out too. Okay, I'm going to have to shift down a little bit. So I factored out the 3 to the n. That left me with a 3 here. So that is that 3. And then this thing over on the end here, I factored out everything, so that leaves a 1 over there. 3 minus 1, that's 2. Now I got it as 5 times 3 to the n times 2. And at this point I can just gather those, and that is equal to 10 times 3 to the n, which was exactly what we wanted to show. Alright, I'll fix that n. It looked a little bit like an h there. 10 times 3 to the n. Okay, and once again, if your result here can't produce what you noticed up here, then one of those two things is wrong. And it's more likely that it's in the algebra, although it can sometimes happen up in this section too. So make sure that they support each other. All right, Character and Scholarship for Life.